Welcome, everyone. We are live and recording, and today I'm really pleased to be here with Lauren Dickson, um, Baxter's drone cluster, statistics, energy, and electronics teacher. Lauren has a Master of Science in Engineering and worked as a geotechnical and mechanical engineer in Maine before coming to Baxter. She was a graduate research engineer for the Advanced Structures and Composite Center at UMaine, where she applied mathematical models to analyze and optimize composite structures for offshore energy systems and develop the ability to explain complex concepts in clear and accessible terms. Her thesis is entitled The Performance Analysis and Optimization of Wave Energy Converters. And she gave a talk at Oceans 22 on a paper entitled Wave Environment Characterization of Scaled Ocean Test Sites. Lauren is also a talented musician and has been a member of Maine Coastal Chorale, where she has appeared in a New Center Maine story. And just 24 hours ago, got back from Louisiana, where you were at a National Math Teachers Conference. So Lauren, take it away.
Thank you. Well, first of all, thank you for that intro. It's very flattering. It makes me sound very official and important, so I appreciate that a lot. I wanted to start by asking how one would make these parts and pieces into a water robot.
Okay, so let's where's the camera, Amos?
Yep,
I'm gonna
just hold
hold it up to this camera, this piece,
And I've got
and another piece
this
that
right
Lauren
here.
has. And our task is to do what again, Lauren? Say that.
How would you make this
Ah.
into a water robot? And sort of the question you have to grapple with is, how do electronics and water mix?
Okay, so how do electronics and water mix? And feel free to just say it out loud.
I have no idea.
Well, it seems to me it would need some sort of protective coating because you wouldn't want it to be exposed to water. My question is it salt water or like bathtub water?
Yeah, so if I may,
Yeah.
I'll keep going. So, what I've had the students do, and this was actually finished today,
Mhm.
this is the completed product of the parts that I was just holding up a second ago. This is the control center for a water robot
Mhm.
that one would keep up here, like so.
Mhm.
And then at the end of this will connect to the water robot to the propellers.
Mhm.
And the way that you would do water robotics is you have to be very careful
Mhm.
about how you are
Mhm.
containing the electronic parts in the water.
Mhm.
So
Mhm.
this is our water robot.
Mhm.
This is not hooked up to any electronics yet, but what we have is some PVC pipe and some pool noodle rings,
Mhm.
and we will submerge it in water and it'll be neutrally buoyant.
Mhm.
And we'll have some propellers on here that are contained in plastic containers with what they use as toilet grease to
The purple stuff?
yeah. So that's gonna
Oh,
keep
yeah.
the propellers from getting
Okay.
immersed in water.
Yeah.
And so it'll be able to attach to our water
Got
robot
it.
here and it'll be able to navigate around.
Okay.
Now this control center, I was sort of asking a trick question because this is not going in the water actually, but we have had students put together all of these parts and pieces. They've learned how to solder, they've learned how to hopefully follow directions correctly. And these parts and pieces control the propellers on the water robot. So I teach Aqueous and aerial robotics, but I also teach energy and electronics. And what I like to do is show them a completed microcontroller. This is something that is very, very similar to these, just essentially like a GameCube controller or a controller of like a video game. And these microcontrollers can be used and programmed for lots of different projects, which I have some pictures on my slides and we'll get into.
Yes, yes.
But it's really good analogy between something that people have made tangibly versus a controller that you can hook up to your laptop and program.
Awesome. Well, thanks for sharing those real life parts with us. I'm going to share our screen so that Lauren can show us more. There. And I'm going to put us in slideshow. There we go. Oh, so an inside look at drones and engineering in the classroom featuring Lauren Dickson. This is our 4th Baxter Teacher Interview Series. Whoops.
Yes. Okay.
Okay.
Before we start this video, Jenny and Christian, you may recognize some folks from this video. This is a member of our drone cluster here, Nico Cervignano. He's kind of our drone expert in the cluster. What I like to show is his YouTube journey, this video specifically because it's got so many views. Of course, it's important to know how to do, your STEM and robotics, but I think it's equally important to know how to market yourself, especially when it's something like Nico wants to do, which is entrepreneurship. He wants to get his pilot license so he can do this commercially. And this is a really cool and inspiring video that I wanted to showcase for this interview.
Should I press play?
Yeah, go ahead.
Welcome back to Pine Tree FPV, guys. This is Colin and Nico. And Nico, can you explain what the video is about today?
So today we're in this incredible bando here in Maine, and we're going to be doing a challenge, a trick challenge basically. So I'm going to choose a trick I want to do, whether that's power looping, diving through the roof, or hitting a gap. I'm going to try to do the trick, Cotton's going to watch me, and then he's going to try to replicate the trick. If he can't, then he gets a point, and then whoever gets the most points loses. Next, Cotton's going to choose a trick that he wants to do, and I'm going to try to copy it.
Exactly. It's very similar to a common basketball game called Horse. We're going to call it Quad, and hopefully it should be enjoyable, and hopefully we don't crash. But if we do, let's hope we can at least get a good video out of it. So you guys enjoy, and good luck.
Let's do it. Alright, so I'm up first. This is my quad. This is the Vanny Style Pro with the DJI O3 system. What I'm going to do is I'm going to go start from here, go all the way down here, power loop up over this roof, and then try to land in one of these middle squares up here on this hang. So maybe this one, doesn't matter. And then I'm going to have to cross back onto here, and that'll be the end of the trick. And you can see there's some branches, like there's some branches up here. Boom, first trick done. Do it on another one just to lock it in.
Yeah. So I wanted to show that because, Nico makes it look very, very easy. But it's very difficult to be able to do those things. And we obviously we teach how to do the putting together the robotics. And Nico has been a really big help with helping me teach other students how to put together those drones, the ones that he's using, which is FPV, first person view. But the other piece of that is students need to learn how to pilot the drones before they actually have them in their hands.
Yes.
And so in our classroom, we've had some drone pilot simulators that students have been able to learn on. And we're hoping to go out and try and maybe not to that extent, but aspire to do some tricks like that. So
yes. And last March or May, when we went out together with a bunch of the kids, we learned that the simulation training would be really valuable because we lost them to nature.
Yes, we lost some drones, our first time flyers.
Yeah.
And of course
they were little baby, little toys almost.
Right.
But
they weren't FPV, but they still, even so, very hard to pilot.
Right. Okay.
So a lot involved there, a lot of skills needed to involve. Nico showcasing his pilot skills, his robot, he put that drone together himself, and then obviously his social media skills.
Right. And now you've got lots of drones being built now.
Yes, we do. So we've got 2 drones that are almost done for the cluster. Nico obviously has all of his drones. And then we've got 2 of these water robots that are almost done too.
Awesome. Should I go to
Yeah. Okay. Just a quick pivot to some of my other classes that I teach. So I teach advanced physics, calc-based physics. This is us doing a lab. In the second picture, you can see that they weren't so thrilled that I was taking their picture, but they did agree that I could take their picture, even though it looks like that. This was a collision course that we did in a unit on energy and impulse and momentum. And those carts, those blue and green carts that you can see are these awesome carts that we have that measure acceleration and velocity and position. And those tracks that they're on have position on them. So we were able to calculate all of these things about the carts just by colliding them together. And the students just loved throwing them around. So that was a fun class. And that class is very small and intimate, which makes it a really good learning environment.
All right, next.
Yep.
There we go.
So yeah, so back to the water robots. That picture that I showed was just showcasing, you know, the kit that they're given and then how they can transform that into the actual robot. And this is that robot that's on the slideshow. So
last year you and I tested out a water robot across the street in the pool. Have the kids gotten to the pool yet?
Not yet. But we're gonna go soon. I think next week is the week we'll go to the pool. Yeah.
Awesome.
Yep.
And all right, what's going on here?
Yeah, so this was a picture that I actually took today. This is the board that's being soldered. So we've got some students soldering the board, and then you can kind of tell in that second picture I told them to make it look like they're interested, and so they've all got their hand on their face and they all look very interested and intrigued. They genuinely were. They were all kind of surrounding Braden, who's doing the soldering there, and learning how to solder from him. I never learned how to solder in high school, but what a valuable skill. Yeah, they're very good at it. They're much better than I am. So
nice. And what's this?
All right, so I've covered a lot so far. I've briefly mentioned these microcontroller chips.
Yeah.
This is for a class that I teach on energy and electronics. And so half the class I have doing these microcontrollers, and the other half is actually doing this Windstorm challenge that I wanted to show, where they have to create floating hulls. So you can kind of tell I'm doing like a aerial and aqueous robotics in every class because it's so tangible. So this is about buoyancy, and then these are also about buoyancy here too. So I just wanted to show a little bit of this clip to show you where we're going. May 1st, I'm bringing 5 students to this competition. $60,000 in scholarships available to the winning team.
Awesome.
So I wanted to just offer that,
wonderful,
you know, as an opportunity for them.
That's great.
Yeah, go ahead and play.
I'm going to click on it.
More than 600 middle and high school students from across the state put their thinking caps to the test for the return of the Simmons Windstorm Challenge at the University of Maine. For 11 years running, students have been tasked with planning, designing, and creating a floating platform for a scale model of a wind turbine that holds up against the university's wind and wave simulations.
1 minute and 15. Came into a lot of problems along the way, but it was really fun to solve them.
We woke up like really early. I woke up at 4 because we're all the way up in a roost stick.
It's really cool to see how well our ideas do in just a freshman classroom compared to the real life.
UMaine representatives hope the competition inspires young minds to strive to make a difference as they enter the workforce.
We've had a really robust program leading the world in floating off.
So we're having 5 students go up and compete in that competition.
Awesome. What month is that going to be?
That's in May. So it's May 1st. May Day. Really
nice. That's a Friday.
Yeah. So in that class, we learned about different types of energy, one of them being offshore wind, which does involve learning how to make something buoyant.
Yeah. So how lucky that these kids have a coach in you, given your dissertation and your past publication.
Yeah.
So that must be so fun for you to see the thing that you were involved in as a student.
Yeah.
Now your students are also studying something connected.
Yeah. I feel
so awesome.
I feel very lucky because I used to work that Windstorm Challenge event.
You used to work?
Yeah. So I get to go see all my old coworkers. Yeah. So they maybe have a little bit of an edge here at Baxter.
Okay. All righty. Well, I can't wait to see it.
Yeah.
All right, tell us what this microcontroller thing is about.
Right. So again, I keep touching on it, and it's a little bit of a tease, but finally I'm going to tell you these microcontrollers are really great opportunity. I did this in college. These are Arduino boards. And in college I didn't even understand it. So I do now, obviously, because I'm teaching it, but these are really awesome, very powerful little computers. And I've showcased some of the diagrams that my students have come up with in order to make little robots based on
Mhm.
these microcontrollers.
Mhm.
So we learn how electricity works, we learn how resistors work, we learn how lights work. This first one on the left is a distance sensor.
Right here.
Yep. So I give them these kits
Mhm.
that include the microcontroller in them.
Mhm.
Hopefully, yep, I
Mhm.
can see that you can see it.
Mhm.
Lots of components in here, lots
Yeah.
of opportunities for
Yeah.
projects. And so this distance sensor is something that they some of them are doing. We've got this LED board that they're going to learn how to hook up to this microcontroller. And then if I can find it, there's also this distance sensor. Let's see. In here somewhere, but there's a distance sensor in there.
Yeah.
They're going to learn how that works and
Nice.
how it talks to the Arduino and the
Yeah.
and the light board.
Yeah.
And then on the right here is it's a little
Right over
robot
here.
buddy. Yep. It's a little robot buddy. And he can smile and he can be sad, and it depends on the inputs you
Right
give him.
here is what you're
Yeah.
talking about.
Yep.
Okay. So the kids put the inputs in and they're trying to learn about the outputs that they're looking
Yeah.
for.
Right.
So I had just had a chance to play with microcontrollers that were doing XYZ coordinates.
Yep.
And if it's attached to your body, it shows the
Yeah.
XYZ coordinates. And then you could train a model to record these are kayaking motions,
Yeah.
or this is hairbrushing motions.
Yep.
And then once the model's trained, you can then test if what are you doing?
Yeah.
You know, somebody else could wear the same microcontroller
And it can
then
tell.
and it can tell,
Yep.
oh, you're brushing your hair.
Yep.
Or you're, I mean, that's really broad movements, but like, holy smokes.
Yeah, these are
what
very
is
powerful.
possible
Yeah.
with that. That's amazing.
Yeah.
Oh, there's so there's a lot of creativity that I'm seeing in
Yeah.
this, Lauren.
A lot of autonomy.
Yeah.
They have to really be masters of their own education in some
Yeah.
ways.
So, you know, in the D school, there is the empathize, define, ideate, prototype, test, and assess in the design process, right?
Yeah.
What is the funnest part of that process for you in working with students?
So definitely the prototype process. I like to do rapid prototyping.
Oh,
So for example, for these, I would give them maybe some pipe cleaners and some tape and like come up with something that's buoyant. And we've done that in class.
Yeah.
And they just love testing different things. And they're like,
Yeah.
you know, they'll put it in the water and they'll be like,
Yeah.
oh, I think I can put some rocks in there and make it a
Yeah.
little bit heavier.
Yeah.
Oh, maybe I should add some glitter.
Right.
So
So I'm hearing that it's like do a bunch of question asking before you commit.
yeah.
And so the more times a student can iterate an idea that's empathetic or related to the problem they're
Yes.
solving in play,
Yes.
almost.
Yeah.
And then the prototyping.
Yeah.
And that's when the technical stuff starts coming in,
Definitely.
right?
Yeah.
So I imagine that you've got kids who have personal passions, right? And yet here you are as a teacher, you're trying to teach how this microcontroller works, soldering, like fundamental things. How do you make the space for different kids to solve the problem in different ways?
Yeah, and that's a really neat challenge that we have at Baxter, and
Yeah.
especially with that class because it's so big. I've got 25 students in it. How do
Yeah.
you accommodate everybody that's
Yeah.
all at different learning capacities?
Mhm.
You know, so the beauty of these kits is that there's so many different projects you can do, and I've
Mhm.
given them this long list.
Mhm.
And so if a student's stuck and they're like, "Oh my God, there's too many projects,"
Yeah.
I'll say, "Well, what do you like to do outside of school?"
Yeah.
"Oh, I'm a musician." "Oh,
Yeah.
well, why don't you make a guitar tuner?" Or
Mhm.
why don't you make a little buzzer that plays a
Mhm.
song, you know?
Mhm.
And so it's very adaptable.
Yeah. So on that guitar tuner, the input would be the sound,
Mhm.
and then so the thing would need to know frequencies.
Mhm. So you'd have to put in a list of frequencies.
So you have to enter the frequencies, and then the board would show you, well, you're playing at this frequency.
Yeah, you're trying to play a D, but you're a little sharp.
Easy.
Yeah, it's not very easy, but there's lots of stuff out there that's helpful
Uh-huh.
resources. And so being able to find those resources is
Yeah.
really important.
Yeah. So rather than buying the $45
Tuner.
tuner, a kid could use this kit and make not just a music tuner, but a whole bunch of things
Yeah.
that they could actually use.
Yeah.
So
Right.
that's pretty powerful.
Yeah.
Yeah. Oh my, how did you want to be an engineer? What made that?
That's a really good question. So my dad's an engineer, he's a
Uh-huh.
network engineer, and my mom is an accountant. And so I feel like I very luckily inherited some math brain.
Yeah.
And I'm also a musician, and so I like other languages. I think
Yeah.
of music as a language, and I think of math as a language.
Yeah.
And I wanted to be able to use that, and I wanted to be able to
Mhm.
build things. And
Mhm.
I wish that I had this in high school. I didn't have these opportunities. And I'm just excited to be able to give that to my students.
Let me ask you, what enabled you to persist? Because from my knowledge, engineering programs are tough. They're
Yeah.
not easy to make it through.
Yes.
So how did you persist once you got there?
Yeah, that's a really good question. It has a lot more to do with your self-talk and how you
Mhm.
perceive yourself as a learner
Mhm.
than how tough the curriculum is, because everything's challenging. It's just what kind of challenging are you picking? And so what I like to instill in my students and what I practice daily is, you know, reminding myself that failure is a part of learning, and I can keep doing hard things if I set my mind to it, and I believe I can win. And I just want all my students to believe that they can win.
That's awesome, Lauren.
Thanks.
Believing that you can win. I
Yeah.
think that's the aspirational aspect of that is probably the most important thing we can give our students, because
Yeah.
once they've got that, they're going to believe in themselves
Right.
to go after it,
Right.
even when the going gets tough.
Yes,
So,
exactly.
awesome. Questions from the audience. I'm going to get out of this share. And I know we've got some sound issues, but if you guys have any questions to type in, we could get Lauren to answer them.
How do you think I got the audio to work? So
It's working now.
I see that Christian asked if this is an Arduino. Yes, it is an Arduino.
Is it an
Yeah,
Arduino?
good eyes.
It's an Arduino. Yeah.
So do you hear me?
Yep.
Yes.
Yeah. So are these all part of Flex Friday projects, or are these also classes they take during the week?
Yeah, good question. So the drones and the Aqueous Robotics are part of the Flex Friday group that I run, Aqueous and Aerial Robotics. But these Arduinos I'm doing actually in class, and Windstorm Challenge I'm doing in the same class.
Yeah. Yeah.
And I know you went to Orono and studied engineering. Did you have a focus at Orono?
Yeah,
an
that's a
engineering
great
focus?
question. Yeah, I did renewable energy, and so that's sort of how I got into my master's and did my thesis on wave energy converters, and worked around a lot of the renewable stuff, which was great.
And part of the reason why we here at Baxter are so excited to have Lauren caring for the energy and electronics class, because it's a topic we'd love to see our students have creativity in as we try to solve some of our most intractable problems in the world.
Yeah. Thank you.
Yeah, thank you for your question.
Jenny, Anna, any questions for Lauren? Okay, all righty. Well, thank you so much for being here with us, and thank you, Lauren, for all of your awesome work with our students.
Yeah.
And there's no jet lag from Louisiana, is there?
No, but I was very tired yesterday.
Yes, yes, a lot of wonderful stuff that I'm sure you're going to bring back to our school.
Definitely.
All right. Well, thank you. Have a great rest of your day.